that is not also found in the descendant lineage. If I have some differences, that means I've evolved my own merry way as well. So I cannot be the descendant, or sorry, I cannot be the ancestor. Okay? I'll try it again if you care later. Starfish have a lot of these changes that occur after the split. We call these apomorphies in the business. Isn't that a great name? Apomorphy. Anyway, all these things are found in starfish that are not found in any Edrioasteroid. So it is not possible that starfish evolve, it is not, now I've got myself confused. It is not possible for, these changes have indicated extensive evolution since the branch point of Edrioasteroids and starfish. But also, if you look at Edrioasteroids, there's several things that they have that starfish do not. So neither group can be descended from the other. What they do is they share a deep common ancestor. And the morphologies that I've been talking about are evidence of that deep common ancestry. So it might look something like this. These are all of our Edrioasteroid friends. These are our starfish friends. They share a common ancestor down here. Starfish have gone on their merry way, and Edrios have gone on their merry way. And this may be at the base of what we call echinoderms in general, the five-fold animals like crinoids and so on. Okay? So the implications for this are that the ambulacral elements and the abambulacral elements of starfish may actually have identifiable common elements with those of Edrioasteroids. Since starfish are flipped over from every other echinoderm, you simply flip it over, strip the cover plates off, and then it can crawl away on its merry way. And these changes in both of those lineages indicate a deep split with some very serious subsequent evolution from that point. And I'll just leave it there, thanking a few people. Ron Parsley and Zhao gave me specimens. Brenda helped me with specimens, yay! And funding from the National Science Foundation. And I'll leave it there. Any questions? Yeah.
That last thing you said about you said that the Edrioasteroid could not be, the starfish cannot have the Edrioasteroid or id as its direct ancestor.
Right.
They share common because, right, but because the Edrioasteroids have something that the starfish don't have?
Yes, starfish and Edrioasteroids each have features not common to the other. So they've both been changed since their branch point. So one cannot be the descendant of the other, but rather they both share a common ancestor from which they evolved.
How do you know that the thing the Edrioasteroid has that the starfish doesn't have is just not recognizable, or it lost it? Because can't evolution also be losing?
Yeah, it can. But part of the problem, there's also a temporal issue. The things that we would generally recognize as morphological Edrioasteroids, things like this thing from China, go all the way down into some of the oldest echinoderm-bearing rocks in the Cambrian. The oldest starfish is well into the Ordovician. There's a very big temporal split there, which very strongly suggests a lot of unsampled starfish. And you notice a lot of the starfish had a whole lot more change than the Edrios did.
Right.
So it's...
Right. So it's still... Does that mean that if there's a whole lot of starfish that haven't been sampled, that you could still find an old starfish that could like reconnect them?
Oh yeah,
with
absolutely.
ancestors?
Absolutely. In fact, they should exist. But what we've been finding lately is people have for years have been trying to argue we have a very well sampled Earth in terms of fossils. And in the course of about 3 weeks, I received Edrioasteroids from 3 unsampled continents. So there you go. and the Edrioasteroids from Morocco, there were 2 papers written by a guy named Chaval on echinoderms in Morocco, and he had a grand total of, I think, maybe 8 specimens, and I have about 1,000. And there's like 8 species of them. So, yeah, the world's not well sampled.
What about locomotive motion?
Oh, dear. I got to look at you and Dave between us because we don't agree.
Should have been here listening.
Yeah. There's conflicting data. Part of the data suggests if they move, it's not very much at all. Up in the upper Paleozoic, at least, you get Edrioasteroid surface densities. Now how dense do you think Edrioasteroids occur in Cincinnati, specimens per square meter? Any idea? Well, Dave would know. Up to about 100 per square meter. That seems like a lot, right? You know what the world record is? 110,000 per square meter.
Oh my God.
When you get them upwards of 5,000 per square meter, they start crowding very hard. And so you'll see a surface like this, and there will be 2 Edrioasteroids on it, on the whole surface, and they're shaped like this. These smashing and fighting at the edge. Now, we don't know that they don't like this. Barnacles do this all the time, but it's a reproductive strategy. But Edrioasteroids probably don't reproduce the same way barnacles do. What's really interesting is in high densities, you also get Edrioasteroids doing this. If these are 2 different species, one Edrioasteroid will literally overgrow the other one. And there's actually pecking orders that you can identify of A overgrows B, A overgrows C, B overgrows C, and things like that. And if they were really actively running around, you would think, but there's no way to know for sure, that this is bad. And so you would get out of the way.